Hello, everybody. My name is Marile Colon Robles. I am the Globe Clouds project scientist at NASA Langley Research Center in Hampton, Virginia, and I am excited to just be one of the amazing panelists in today's webinar, our first air quality webinar. Woo! I want to hear you clap. It's been a long, hard work getting all these done, but we're really excited. And so we have Dr. Margaret Pippin here present. Um, please ask her all questions, aerosols. I'm just hanging out here like a cumulus cloud, just however I can. We have Miss Angie Rizzi, educator extraordinaire here behind the scenes. Miss Cassie Stoffen, our Zoom guru here to help you out, and the wonderful Samantha Adams, teacher extraordinaire, aerosolologist. I just say that because she loves aerosols, okay? So we're gonna start here our webinar.
So we have a couple of videos that we're going to show you. See, we pre-recorded precisely because we sometimes have some technical issues, and then we can stop and have questions and stuff at the end. How can clouds tell a story? So I'm Angie Rizzi, and I'm an outreach coordinator at NASA Langley Research Center, and I work with Dr. Margaret Pippin, who's the Globe Air Quality Scientist. She's with us today. I'm very happy to have her here. And then Samantha Adams is a Globe teacher who participates in the air quality campaign, and she's contributed some material for this as well. So I wanted to acknowledge her and give her thanks. So this is an image of a cloud that somebody has told a story with. They have taken the picture of a cloud and drawn over it what they think that cloud might be. So I think we can all remember times when we've looked at the sky and seen clouds and thought that they looked like something. Oftentimes those are cumulus clouds, but not always. And so this is one person's imagination and creativity applied to a cloud. But what I think is really neat about this is that if we go a little bit further and we take that same cloud image, here's a different rendering and a different idea of what that cloud could be. So this is a different artistic interpretation of that same cloud. And then if we take it further, here's an even different interpretation of the same cloud. And so as you see, different people can see the same cloud in a different way, and the clouds can tell a story. Of course, from our perspective, we are thinking from a more scientific point of view when we're trying to link this with air quality, but I just wanted to lead with the idea that clouds for a long time have told stories. So we're going to get into a scientific story. I do just want to put in a plug for Elementary Globe that there is a book in the series that has to do with air quality, and that is What's Up in the Atmosphere, Exploring Colors in the Sky. And it turns out that sky color is actually an important indicator that can help us understand the air quality in an area. We'll get into that a little bit later in this webinar. But in this story, the students notice that the sky is not the same color every day, and they explore that with the help of their teacher, and they learn about aerosols, and there are some activities that go along with this. And so you can find this on the Globe website under Elementary Globe. And again, taking this storytelling aspect here, there are 2 coloring pages that go with every Elementary Globe book. And this is one of the pages where you can color the sky as you saw it. So there you can tell your sky story once again. This is a scarf that I started to crochet, which is a sky color scarf. And so the idea here is that If you pay attention to the sky color and you have different colors of yarn, you can do a few rows of a scarf or a blanket for each day of the sky color. And if you look closely, you can see at least 4 different shades in this, and that some colors persisted for more days than others. And again, this is just one way of having a creative approach, but still tying this in. It's a way to represent the sky color and maybe even the air quality. So turning now to a more scientific view than some of the things that we've already looked at, let's talk about the approach that we have for using clouds to learn about air quality. And what we have here is this concept that if we take the existing GLOBE data from the visualization tool, the students can find observations. Some of them will have photos, and then they can integrate additional data in order to build out their air quality story. Of course, they can make their own observations as well if it is safe and they can follow local guidelines. But if that's not possible, they don't have to make observations. They can use the existing data in order to build out the story. So on the top here, you see that there was an observation during some of the wildfires, and you can clearly see smoke in the picture. Now, students can look at the pictures. They can ask questions about what they observe. They can, in the Viz tool, they can put on the aerosol optical thickness base map, as you see here in the middle. They can look for patterns in the cloud observations or the base map, and that base map is helping them integrate additional data. And over the course of the series of webinars that we're putting on, we will also be covering other kinds of data that they can integrate beyond the GLOBE visualization tool, such as we see here on the bottom. And then you can piece these all together in order to tell a story. So that's the general approach. So here's an example. This is what Samantha Adams did. Is she took a picture of the clouds. So she made a cloud observation out her window and took a picture of the clouds. And I love this because you can look off into the horizon as well, and you can see how the visibility of the clouds is. So looking off in the horizon, that you're going to notice that in some of these pictures, it will be easier to see than others. So the first thing she did is took a picture, and then she went to the Purple Air website and got a screenshot of her local area. So I'm going to cover how to go to the Purple Air website later and how to pull these data up, which is great. But what I will tell you is that Purple Air are ground sensors that measure PM 2.5, and these are deployed all over the place, really worldwide. They are low-cost sensors that individuals or schools can purchase and deploy, and they are not as accurate as the research-grade instruments, but they have a known bias, and so they're so prevalent that the EPA has actually come up with a correction factor that they can apply to these Purple Air measurements. And the trends are definitely good. So I just wanted to let you know what that is. And so PM 2.5 is particulate matter that are 2.5 micrometers or smaller. And they're very small. They can get deep into people's lungs. And so they are one of the criteria pollutants that the EPA measures. So taking that together, here's her picture, her photo from July 9th, along with her Purple Air screenshot. So what I want to do is go through several days and let's look at her story. So this was July 9th, and now we go to July 10th, and we can see that there is a white sky here. The air quality looks pretty clean, so I'm going to guess that this is quite overcast. Now we see a different kind of clouds on the 13th, and we're looking at the air quality here, and we're seeing ranges from green to yellow and one little orange one there. Now we have very clean skies. Almost all the purple air indicators are green. And also look at the visibility here in this one. It's not very hazy at all. It's a pretty clear day. So here we see another day, another kind of clouds. It's not as clear. We're seeing some yellow over here in the purple air. So we can see things changing from day to day as we proceed through these days. So I'd like you, as I go through these days, to think about, is this something that you could do? Could you get photos? If you're using Globe Observer, you can certainly submit those through Globe Observer and then retrieve them, and then go to the Purple Air website and get screenshots. Because this can be the foundation of your story. And as we move through the webinars, we're going to talk about how we can integrate other forms of data. But one of the reasons that we're talking about this in the first webinar is because in order to get these purple air maps, they are real-time data, and so you have to get them at the correct day and time. You cannot go back in time and get them. And so we wanted to show you this in the very first webinar so that you can be capturing those as you move along so that you have those. The other data sources that we're talking about integrating are things that you can go back in time and get. So now we'll look at the globe visualization tool to take this even further.
So in the western part of the United States in the last couple weeks, there has been quite a bit of interest in air quality because there have been so many fires and it is affecting air quality. So what I've done here is I've pulled up the globe visualization tool and I'm showing cloud cover observations. And I'm beginning here on September 1st. And you notice there are a couple of very dark circles. And I'm going to scroll through some days. And those dark circles represent obscured skies. That's when an observer makes a cloud observation and they say that the sky was obscured by something. And when they do that, they can indicate what it was obscured by. So I'm going to select one of these observations and pull it up. And you can see that they did say that the sky was obscured. And it says smoke is true, meaning that they said that they saw smoke. And if we're lucky, they took pictures and we can click on the photos and they are for the same day here, September 13th, and look at these photos. So I think that, you know, these photos certainly do look like they could be showing smoke. And so that's a really interesting place to start a project like this. So I want to show you a couple of other really neat things that you can use the visualization tool for to help you with an air quality project. The first thing you can do is you can add another protocol, aerosol optical thickness. You would find this under atmosphere and under aerosols, aerosol optical thickness. And you can see if there happen to be any observations of actual AOT, which the higher the aerosol optical thickness, the more likely there is that there's some kind of air quality issue. And I'm going to look back in August of 2018, and I'm going to step you through the 15th through the 21st. And notice here, this symbol shows me that there was an aerosol optical thickness measurement. So let's continue to go through a few days, and I'm seeing some aerosol optical thickness measurements. And now look, I've got an obscured sky right where that was, and I'm seeing that I have some measurements, and I have been having some obscured skies. So if I were to click on this particular aerosol optical thickness, I have the history for that location, and I'm seeing some very high numbers here. So that could be indicative that there was something going on. So since I may not have photos that go along with that, and even maybe don't have photos that go along with the cloud observations, then what can I possibly do within the Viz tool to investigate further? And what I'm going to say is if you go in here in this option with the 3 little dots, and you come in and you look at the NASA satellite data, you can come down here to aerosol optical depth and add this base layer. And these red and orange colors are going to be indicative of some sort of very thick aerosol optical depth. And so you might be able to see that here where we have this number and we're having obscured skies showing up, that we also had high aerosol optical depth numbers in this satellite imagery. Okay, so that's another thing that you can explore. Now,
so hopefully you've gotten a few ideas of how you might get started on an air quality project this year, but please don't hesitate to reach out to our team, Margaret Pippin or myself. We will both be happy to help you get started on a project and take it even further than this if you want. Thanks.
So we do have 2 more video clips. One is going to be about making observations with obscured clouds or obscured skies. And the other will be a little bit about getting those purple air screenshots. But does anybody have any questions at this time? So if there aren't any questions, Cassie, could you play the Marilee's video, the cloud one?
You bet.
Please.
Mhm.
Thank you.
Hello, my name is Marilee Colon Robles, and I'm the project scientist for NASA Globe Clouds at NASA Langley Research Center in Hampton, Virginia. I wanted to share how you can send in air quality reports with your cloud observations. Remember, only make cloud observations if you can do so safely and follow your local guidelines. You may know this already, but clouds and aerosols go together. Aerosols, or particles that are in the air, are needed to form clouds. Water needs a spot to condense or come together. Scientists call this a cloud condensation nuclei. When enough water is condensed or clumped together, you have a cloud drop, and voila, you can see a cloud in the sky. The same happens to ice, with those thin, high clouds that form in really cold temperatures, because temperatures get colder the higher you go up in the troposphere. So let me point out how certain questions within the globe cloud observations give us information about the amount of aerosols there are in your view of the sky. Let's start with sky color. It might be weird to report the shade of blue the sky is when you go out and make your observation, but that information gives us an amount of aerosols that are in the sky when you're making your observation. The deeper the blue, the less aerosols there are. The milkier or whitish the skies, the more aerosols are present when you're making your observation. There is a neat activity you can do at home to see this change in color as you add more aerosols into your sample. So you might want to check that out. Now, we also have a resource for you to understand the difference between overcast and obscured. Overcast is when your sky is completely covered by clouds and it'll look white. Now, sometimes when you have certain aerosols present, the sky will also kind of look white, but there's some differences. So you can go to that resource
and find out, what are you looking at? Overcast skies, completely covered by clouds, or there's aerosols out there, okay? Now, the second item is visibility. It is very similar to sky color, but the difference is that you are looking at the horizon. So you're looking straight in front of you, the horizon, and then you try and focus on a spot and see how many aerosols you're now looking in that view. When you did sky color, you were looking up and looking at the darkest blue you could find in your sky. So now for visibility, you're looking at the horizon straight across. So pick a spot that you can see far away, and hopefully a spot that you are used to seeing a lot, so you know what you're looking for. And then try and notice something. Maybe it's mountains or a tall tree or even a building. And then when you're making your observation, try and see if you can still, how clearly can you see these spots? If it looks really clear, it might be because there's not a lot of aerosols between you and that spot. If it looks hazy, there are a lot of aerosols. So that's another way to tell us about aerosols that are out in your skies. Now, the third one is obscuration. So that resource I talked about, overcast and obscuration, this is where that funny word comes in. It is a weird word, but what it means is that there's something blocking your view of the sky and clouds. Now, you guys are globe observers, so you know that we're not talking about a building or a tree. We're actually talking about something like dust that was picked up by wind, smoke from a nearby fire, or even haze. The way that you report these things is when you're choosing if there's clouds, no clouds. The third option is obscuration. You pick that and then you select which obscuration you're looking at. If it's dust, haze, smoke, you pick that and then you take your pictures. That is the most exciting thing as a scientist to do, is to look at your photographs. It gives me and others a chance to see, to be in your shoes and see what you are seeing, tell your story. And so depending on what's happening, you might want to take a picture of the sky, but sometimes you might want to take a picture of the horizon and really look at the ground and a bit of the sky to capture the whole event, if it's dust or smoke, anything like that. So if you go, you can select add pictures manually. That way you can point your camera in any direction, not just at the sky, and take a picture of the event, of what's happening, okay? You aim it at the cardinal direction. Remember, cardinal directions are north, south, east, west. So let's say I see something happening right now, and I think I'm facing north. So when I click on add pictures manually, I'll click on north, and I can add my own photo, or I can take the photo right then and there. Either way, we want to see your photographs. So thank you for submitting those with your observations. I hope you understand a little bit more why we ask these questions within the cloud observations, because you cannot have aerosols and clouds. You cannot have clouds without aerosols, and you cannot have aerosols without clouds. It's a different process, but as you learn more about clouds like I did, you start learning that clouds also produce new aerosols. It's so cool. So thank you for being a cloud observer, and I cannot wait to see your observations coming in to the GLOBE program. Bye.
I see a few questions here in the chat. The app is definitely free. You can find these things on the GLOBE website. The main website for Globe Observer, if you go into clouds from there, and I'll look for a more specific link. Does anybody have any other questions about the clouds? And the reason that we wanted to include this is that it's This is a little bit of a new approach to air quality. We used to rely on sun photometer sensors for the air quality campaign, but we're trying to expand the options, and clouds really do give us, the cloud observations give us a lot of information about air quality. So that sky color and visibility information is really important, and students can do some things with air quality even if they don't have sun photometers. Okay, so we have the last video then that shows about accessing the purple air data, and this is just to get the screenshots. We will have another webinar, the third in our series, and that is the website, the webinar when we'll do a lot more information about the purple air. But if we could cue that up, that would be great. So now we're going to cover how you can access the information from the Purple Air website and get your screen prints like we showed earlier in the presentation for building your story. So you're going to go to the website, purpleair.com, and this is the page you'll land on. And you're going to want to click on View the Map. When you do that, map will come up, and depending on if you've been on the site before or not, it may bring up your locality, but I like to zoom out because I always like to get my first screenshot as a screenshot of the whole United States. And I do that for a couple of reasons. One is I like to look for patterns and trends, and the other is that you can see weather systems in the country if you compare days. And so I always like to start off with the United States. And then if you want to zoom in on your locality or your region, you can do that. And I'll show you that in a couple minutes. So what we're seeing here are actually air quality index numbers. And that's not exactly what we want to look at. What we want to look at are PM 2.5 measurements. And so what you need to do is come down here into your variable field, and you can see it says US EPA PM 2.5 AQI for air quality index. And we want to click that little button and select raw PM 2.5 in micrograms per cubic meter. And that's going to give us the raw data. The next thing you want to consider is whether or not you want to look at a 10-minute average or a 1-hour average. If later you might be comparing to some EPA monitoring stations, you might want to change it from 10-minute average to 1-hour average. The next thing that you're going to want to do is click off the box for the inside sensors, because we're not really looking at indoor air quality, we're looking at outdoor air quality. So now you have the PM 2.5 measurements and you can get a screenshot. The thing that is important to remember about these data are that they are updated on basically every minute or two. And so it's important for you to get your screenshot at the appropriate time on the appropriate day. You cannot go back and get a map from an earlier time or an earlier day. You can get data from earlier times and download that, but you can't get the actual maps. So if you make a cloud observation, you're going to want to come out to this website and try to get your screenshot within a short period of time. So the next thing I want to show you is if we were to zoom in on an area. Let's select something out here in California because there are so many out there. And you can see that there are many, many purple air monitors. So you can get a screenshot of an area, and let's say that you know of a monitor that's very close to where you are. You can actually click on the circle for that exact monitor, and it will pull up a graph for you for the last few days, and it will tell you what your average is for the time period that you've selected. And so you might also want to get a screen print of that. Let me select another one that has a low value here. And so you can see how you can get some additional screenshots as well. So you can zoom in on your location and find a Purple Air monitor near you and get that as well. Remember, please, that you should never be making a cloud observation unless it is safe to do so and allowed by your local regulations. However, you can do an observation out the window if you would like. And so even by looking out the window and looking at your sky color and visibility and what clouds you can see, and then comparing that with Purple Air data, you can start to build an air quality story. Does anybody have any ideas, things that you might want to do for the project? So if no one has any questions, if you want to join us then on the December 1st webinar, we'll be talking about Aerosol Watch and more on the globe visualization tool. Marilei has worked really hard on a student project support page for clouds, and hopefully she can put the link for that page in here in the chat as well. That talks about even some other project ideas that you can do just using cloud observations. And our third webinar then, so we have December 1st, we'll be talking about the Globe Viz, and then on December 15th, will be Purple Air and the EPA fire and smoke maps. And then January 12th, we will be talking about putting it all together to have the students create their own stories. So hopefully this is going to be something that will be useful for everyone. And I think Margaret would be the best prepared to answer what is the 30-day or week average. I'm assuming that that is with regards to Purple Air. Oh, 30-minute, yeah. Margaret, can you speak to that?
I've allowed Emily to ask her question.
I assumed it's the average over the past 30 minutes, but I just wanted to confirm that.
Yes. So typically, well, Purple Air map updates every 2 minutes, and that's the raw data. And typically we look at our averages because that way we can directly compare with the EPA monitoring stations. And the way the averaging is done is by, say, just as an example, if you've got the hour between 1 and 2 p.m., you take all the data between 1 and 59 seconds and average that, and then you place that number at the hour of 1 p.m. So it is an hour average, but it makes a difference where you put that average at, what hour. So you can do a direct comparison with EPA.
Okay, thank you.
If anybody else has a question, just raise your hand and I'll have talking permitted.
I do see that David Brooks put a link in here for a way to build your own particulate sampler. So if anybody's interested in that, the link is there. I think some people might be able to do something like that. We certainly are trying to make this a project that people can make observations if it's safe, but if it's not safe, then they can use existing data. If Thank you for that link again, David. So if nobody has any more questions, I hope that you can join us. Yeah, Margaret's indicating she's looking forward to working with you guys and your students, and I can vouch for it as a former teacher that she will work with you. She will help you, and she will work with your students. So just shout out to Margaret because she's a great project mentor. Thank you, everyone. Thank you, Marile, and thank you, Sam, as well.